Hi, my name is Jason, and I've been working on a project called EI Policy Assistant. The idea is pretty simple. It gives LLM a memory of specific information so the users can ask questions in regard to that information without having the users look into the document. It's a very simple when our data is little, but it becomes exponentially more difficult when the size of information is getting larger and larger. And that's where the RAG system is being used. RAG stands for Retrieval Augmented Generation, and that's what we're going to show you today. This is what I'm going to show you today. Like, this is our front page, and so the data already been treated well and stored in the system. So what we are going to do is that we are going to look at the data first. What data are we using for this product? We're actually using the EI data here, so I'm gonna walk you through what's the data look like. There's about 600 pages for this document, and I used 5 years, so from 2019 to 2024. So in total, there's probably around 3,000 pages, and uh, and the content looks like in the first 400 pages, it looks like typical report. It has charts, has tables, has text information, text data, and so just typical report. And starting from page 400 around that, we're gonna see it turn into our data, our numerical data. So our tables, it serves as a database for this report. So in the min tags, if there's anything being referred to this page, it's like annex for the text message. So yeah, um, so this is what data look like. A few things to be noted that it make things can make our retrieval system not as good as should be. Is that is the tables are actually separated from the min tags, which is for LLM they are actually disconnected information. So we need to find a way to link those table to the text part where it's been mentioned. And also the second part is a lot of those tables can be not a lot, but some of those tables can be very long, right? Some of them are like are one table in 2 pages, right? We see the continue here, right? These belong to one table. However, when we're doing chunking, when we're doing retrieval, the these become something more problematic because um, we're taking the information from each page. So yeah, I've taken that into the consideration. So we made a system to support that. So in order to test how well the system is answering questions, so I made 100 questions with its answers from the documents, so we can test if the LLMs if the system is answering our questions correctly or not. Right now the accuracy stays around 85%. So, so I believe if we do the parsing in a better way, we probably can reach it to 90%. So yeah, let's look at the front page again, and then we'll give it a few questions here. So let's start with maybe inputting some questions in there and see how well to answer the question. So this is running on my local computer, so usually it will take around 10 to 20 seconds. And for the first question, we're looking for 1.4 in the fiscal year of 1920. So let's see what it got. Okay, so it got 1.4 here, so it got the answer correct. And let's scroll it down. And those are actually the tested wrong questions, so I'm gonna put that in there as well. Like maybe just try these. And we're gonna try that later. So for this time, we're actually looking for 134.9 thousand jobs vacancies in Quebec. See if it gets that. So for the harder questions, actually, so it probably need more time because, okay, so came out 134.9 thousand job vacancies were recorded in province Quebec. Did I get it right? 1.4. Okay, yeah, so I got it right. So even though it's saying maybe hallucinated, like it's saying it probably like detected a few sources saying probably different things, and then it decided to answer with this question. That's why it has maybe hallucinated. And see what we got here. as we're scrolling down, this is just from my own information how the LLM is looking for the information, and we can actually advance this using more agentic way. Basically, how having the LLM to decide if it answered the question well enough or it needs more information and go into more details on some of the chunks, maybe going around it or like let it decide what need to be done. So these are to retrieve the source. So what it does basically, it retrieve the source from the text message from the data we input, and then decide this part is the most relevant part, and use this as the source for LM to answer the question. Let's see what it looks like. Okay, so it draws the answer from the table here, looking for the Quebec question. I don't know where it is. Okay, 134.9. That's where it draw the number from. That's what we're looking for. And the other parts, it might be helpful, but so LM decided not to use them. That's part of it. And maybe let's try the wrong answer here. I mean the wrong questions here. See what we get. So we are actually looking for 92.9% of the individual processing activities were found to be in order, and page number source should be from 373. This is like a test wrong question, and we're still looking for a way to further improve those into those questions and see if we can get a better answer from that. So it's still generating. It might take a little while because it's going to try its best to search for the different answers, and in the end, it's probably going to say, nope, I didn't find it. Still doing it. See how long it takes. And also we have the, okay, another thing while we're waiting for it is that deep search. So deep search allows LM to actually search a lot more, twice as much as the original, which is taking more time and using more complicated way to search the result. And accuracy will be higher for those like complicated questions if you have like some logic in your question. For example, you're not just retrieving information, you're actually having some logic where it requires different pieces of information compared together and then get a result of it. So that's where you need the deep search here. So that's for a more sophisticated question. So it answered that question and it was answered wrong. So result of 81% and 80%, which is not what we're looking for. And that's the problem we are actually having right now. Having a better parsing might help on this, and also having a more agentic way to answer the question might help. So yeah, I'm still looking into how to do it better. So for 3,000 pages, it's 85% is what I can do so far. Thanks so much for your time, and looking forward to talk to you.